Hello students, we are going to continue with Bridge course. In this segment, we are going to look at core ideas for class 11th. So there are certain chapters which you're going to learn in class 11th. I'm going to walk you through some of those concepts that you will learn in those chapters. Now, if you know these concepts, it would be much easier for you to understand all those chapters that you're going to study in class 11. Okay, so this will just give you an edge over your peers. So let's get started. Something called frames of reference. So the first thing in mechanics that we study is about rest and motion. But you should know that rest and motion are relative concepts. These are relative concepts. Means what? That something is at rest with respect to something else. You need a reference frame. Okay? Something is in motion with respect to some other thing. So you need, again, a reference frame. Nothing is absolutely at rest. Nothing is absolutely in motion. Rest and motion are relative concepts. In other words, someone can say that object A is moving, while other person will say that the object A, that the same object is at rest, and both can be correct. I'll give you an example. Consider you are sitting inside a train, and in front of you, there is a passenger who's sitting in front of you, okay? Now, you would say, even if the train is moving, you would say that the passenger in front of you, the passenger sitting in front of you, is at rest, right? But if someone standing on the platform outside looks at both the people inside, he would say that both of you are in motion, right? So you are saying that that person sitting in front of you is in rest, while the other person standing outside is saying that the same person is moving. And both of you are correct. Okay, so that is what we mean when we say that rest and motion are relative concepts. There is nothing like absolute rest or absolute motion. So we need to define a reference frame if we want to talk about rest and motion. If we fix a reference frame, then we can talk about rest and motion without again and again going back to asking what is the reference? What is the reference? Okay, so it's important to understand frames of reference. It's basically that point from which we are looking at the motion. Frames of reference can be static, stationary, or frames of reference can move also. Let's understand this with the same example as a train. Now, we have two people, person A and person B. If person A is looking at person B and the train is moving towards the right, person A will say that person B is moving, I am at rest. Yes or no? So person A will say that she is stationary while person B is moving to the right. And she is correct about this observation, right? Now, think about the perspective of this person now. If we shift the reference frame from person A to person B, then how does this motion look like? I'm sure you must have encountered this situation before. Either you are sitting in a bus, the bus is going forward, you look at trees outside, the trees seem to go in the backward direction, right? Something similar is happening here. This person is moving forward, okay? This person is moving forward. And person A appears to be moving backward in this direction to this person, right? So this person will say that I am stationary, but this person A is moving towards the right. And he is also correct. So if this person was saying something else, she was also correct. This person is saying not the exactly same thing as person A was saying, still he is right. How come two contradictory things be equally correct? It's because we have shifted the reference frame. We should not do that. In most of our problems, we will stick to one reference frame. And that reference frame would be the chosen frame attached to the earth, okay, attached to the ground. So a very, very special frame, which is attached to the earth, unless otherwise mentioned, we will consider the reference to be this only, okay, a frame which is attached to the earth. Now, as I said, frames of reference or your point of view from wherever you are looking, frames of reference can be static or frames of reference can be in motion. This frame of reference, when we were talking about the point of view of person A, so this frame of reference was at rest. Here, the frame of reference was this girl. She was at rest with respect to the ground. Yes? So that's what we are writing. At rest with respect to the ground. Then, when we shifted the reference frame to this person is actually moving with respect to the ground, right? So we would say that this frame or this frame, frame B, is in motion. Motion with respect to what? With respect to the ground, of course. So whenever we talk about rest or motion, we have to talk about the reference frame. We're talking about motion, reference frame is the ground. We're talking about rest with respect to what? The ground again. Okay, because this was our standard chosen reference. So frames of reference can either be at rest or they can move. That is fine. If a frame of reference is at rest, it's called an inertial frame of reference. Frame B is in motion. Would you say that a frame which is in motion would be called a non-inertial frame? Well, we are tempted to say that, but there is a slight caveat to this. There is a slight interesting point to this, which is this. See, motion can be of many types. Motion can be a uniform motion, or it can be uniformly accelerated motion, or it can be non-uniformly accelerated motion, right? So in which case should we call the frame of reference to be inertial? In which case should we call the reference frame to be non-inertial? Let's take a look at that.